Afternoon, everybody. Thanks for joining us. My name is Tim Larkins. I am Director of Market Intelligence at Arrow Electronics. First things first, this is the Internet of Things panel, where we're going to talk about some of the inherent risks and opportunities that come along with IoT. If you're looking for Econ 101, it's down the hall. Make a right. Sorry, it's a stale joke, but it still works sometimes. This will be a 55-minute session. We'll have some time for Q&A at the end. So if you want to hold your questions till the end, that would be great. I like to always start with understanding who we have in the audience before we go to the panel. So if I could get a show of hands, how many of you work for companies that are manufacturers or suppliers? Handful. How many of you work for VARs or solution providers? And SIs or services companies? Okay, so a pretty good mix. Now I'm going to switch gears and let's talk about your company's relationship with IoT. How many of you would say you have extensive reach into the IoT space? Okay, how many of you have had a couple of projects working in IoT but are still have room to grow? And then how many of you are complete novices and are just learning and hoping to get some revenue in that space? Okay, another good mix there too. All right, so our panel knows who we have in the audience. Now I wanted to thank you guys for joining us. Appreciate your time here today. What I'd like you guys to do is just go ahead and introduce yourself. We'll start with name, title, your involvement with or perspective on IoT, and then we'll jump into some questions. So why don't we start with Landon here?
My name is Landon Van Dyke. I'm the Chief Sustainability Officer for the State Department. For the greening of the American embassies around the world, IoT is used for monitoring our buildings, to air monitoring outside at our embassies, to vehicles, and monitoring our fleet. So some of the first things we're doing.
Good afternoon. My name is Stephen DeFranco. I'm with IoT Advisory Group. We're a company who helps corporations figure out their IoT strategies. We also have an advisory section of our group that does M&A work. And prior to this job, I ran Broadcom's IoT division, which we sold to Cypress Semiconductors for about $550 million. So that was at the time the largest IoT sale in the industry.
My name is Travis Hall. I am a policy specialist in the National Telecommunication Information Administration, which is a part of the Department of Commerce. NTIA, for those of you who don't know us, we have two big hats. One is we do manage the federal spectrum. So FCC manages all commercial spectrum, gives a big chunk to the federal government, and we actually do then manage that side of the spectrum in question. And then we are also, by statute, the President's primary advisors on telecommunication policy issues. And that's where I sit. I sit in the Office of Policy Analysis and Development. The Department of Commerce recently came out with a policy green paper on IoT, on trying to work to foster the ecosystem to ensure that these new technologies will thrive. That includes ensuring that the opportunities are not missed, but then also ensuring that we meet the challenges head on. So that came out in January, and I was the primary staff lead on that project.
Hello, my name is Tracy Shockley. I'm the Federal Service Architect with One Identity, work with Identity Access Management and Privilege Access. I came from, actually just started about 8 months ago. I was working with DIA as an Identity Access Management Chief Architect for both the DIA and also the IC community itself for ICTT COE. If you haven't heard about it, that's where the 17 agencies are coming together as one to work in one architect. I'm here to bring kind of the concerns and the issues that the government has with IoT and where they're actually looking to take IoT in the future. So.
Awesome. Well, thanks for the introductions, guys, and thanks again for joining us. Appreciate it. I usually like to start panels with a little bit of context setting, so we're all familiar with the concept of IoT, but I'm sure we've heard a lot of the staggering numbers around it. When we talk about the number of connected devices by 2020, we're looking at 20 billion worldwide. When we look at market sizes in terms of revenue, estimates are anywhere between $500 billion and $1.5 trillion, depending on how you look at the market. So what makes up, or where does IoT sit in terms of the technology spectrum? Well, at Image Group, we like to look at technology through the lens of IoT through the lens of 6 different technologies. We look at big data, we look at infrastructure, cloud, mobility, cybersecurity, and I'm missing one here, business and operations, so the applications that sit on the back end. Where does IoT fit in that? Well, it's not necessarily a discrete technology that sits beside one of those categories. It's more of a wrapper that exists around all of them, and I think it requires its own subcategories of components, right? So within IoT, There are generally 4 major components with it that sit inside of it. So we have our nodes, which are our sensors, the devices that are collecting the data. We've got our gateways that are responsible for the data processing, the protocol translation, making sure that the nodes are connected. The third piece then is that IoT cloud platform, and that's really what's storing and managing the data that's being passed through the gateway. And then finally, we have the big data and analytics, which is sort of a catch-all for the applications that allow us to make sense of the information that's being collected and processed. So I want to start with our first question directed at Stephen. As sort of the IoT expert in the room, I want to make sure that you that you agree with those being the components that really comprise IoT. And then I guess the follow-up question to that is, where in this ecosystem should our suppliers and partners spend most of their time in order to bring value to our government customers?
Yeah, I think you nailed the pieces, right? So if you look at IT versus IoT, the world of IT was clients and servers. And cloud, I guess, if you want to put it that way. But the point was that the client was relatively smart. Your phone's pretty smart, your PC's smart, your tablet's smart. We can put lots of security on it. I mean, it balanced the IT issue between the client and the server. When we go into IoT, the challenge is that the endpoint node is going to be really dumb. In fact, we're going to make it as dumb as we can make it because we're going to want to make it as cheap as we can make it, which means it's not going to have a lot of processing power, it's not going to have a lot of memory, it's not going to have a lot of ability to put a lot of cipher into it. And in fact, it functionally eventually will become disposable, which means we end up with this new thing called a gateway, as Tim indicated, which is really going to end up being a new kind of model where we'll end up with nodes, gateways, and then servers and clouds. And that gateway, and you'll hear a lot of this now coming out, that gateway is probably where we'll control all the nodes, where we'll do a lot of the processing, we'll do some of the edge compute work. And this is going to be the new platform for which IoT will work on. So think of it as nodes, gateways, and then some form of server or cloud, depending if you're going private or public, and where the analytics will likely fit. It's a really different architecture than what we're used to in IT.
And so where do you think our audience should be spending most of the time on working?
So here's what I think you need to really think about, and what I tell a lot of integrators and IT specialists to worry about is I think you need to focus on a vertical, because these verticals will vary very differently into, although everybody will use basically the same kind of sensors, the application software and the gateways you will use will vary tremendously from vertical to vertical. I think you have to start to look at, there are right now 230 different IoT platforms commercially available on the market. In a year, there'll be probably 23, and a couple of years after that, there might be 4. But those will probably become vertically specific. You're laughing at me, but it's true. Yep. But those will become vertically specific, and you're going to want to layer into a platform, just like you've probably got a VMware practice or a Citrix practice, right? You're going to end up with the same thing. You're going to end up with a layer that's going to really be where you're going to control everything from, because the endpoints aren't going to be that hard to figure out. The gateway hardware is going to be easy. It's going to be that platform, and then which applications. So for any of you, I'm going to take something off your world, like in the medical industry, we're doing a project right now. We're really looking at how is Cerner and Epic and McKesson going to end up controlling all the devices in a hospital, because they're going to want to control them because they want to bill for them, right? They want to know how many heart pumps are working and where they are and when they're working. So eventually, McKesson will still be the app. The issue will be the platform that will live between the nodes and the app.
Okay. So it's interesting how much consolidation is kind of being planned for in the market right now. Yeah, it's going to happen. Well, looking at government customers, I'm finding that in some of the research we're doing, a lot of government agencies aren't ready to talk IoT, or if they are, they don't like to refer to it as IoT. So Landon, how does the State Department talk about IoT projects internally, and are there any buzzwords or keywords that industry should be looking out for in order to help them identify an opportunity to engage on a solution?
Well, to be honest, we didn't really know what IoT was. We were like, what is this IoT? In fact, I still write memos to various entities within the building, and I put IoT, and they have no idea what it means. So we look at it as, hey, we have something that's good for the department in our operation or business, but it needs to connect to the internet for us to be able to take advantage of it, which immediately gives everybody heartburn because they immediately think security, you know. And if anybody comes to them and says, and we get this all the time, people come to me all the time and say, hey, I got this great new IoT device and we want to use it within our operations for making something more efficient or tracking all of our diplomatic courier pouches or whatever. The very first thing that our team does is they get heartburn over the security part, and then most people, when they think about security, they think, okay, well, we shouldn't do it then, and then it just goes away. So normally if a business comes to us and they say, hey, we have not just the IoT device, but we have the security wrapper planned into how you would apply that to your network, that would actually be a better way to approach us. But
Sure.
yeah, security usually is the...
So for those of you that have ongoing IoT projects right now, how many of you have those projects existing outside of the realm of security? So everybody's IoT-related projects are security-related at this point. Wow. So, I mean, that's a good story to tell a State Department. So what can we do then to, can we diversify our approach to government? Are there other messages that are going to work? I mean,
So let me just chime in a little bit on the first two questions as well that might help maybe with the question that you're asking right now, which is with the green paper process, we collected a lot of comments from industry, from academics, from others on a wide range of questions. Being the Department of Commerce, we get to take that wide view. We don't have mission-specific space that we're trying to necessarily solve. We're trying to promote industry, promote these technologies. And we struggled with the definition. We struggled quite a bit. And part of the reason for that is when you are the federal government defining something, it has a lot more meaning than if you're just doing an academic paper or you're doing a blog post or something like that in order to talk about the topic. And we shied away from doing a technical definition. NIST is working on cyber physical systems, of course. And there's a great NISTer on the network of things. But for IoT, it's a bit more of a trend towards connectivity, right? A trend towards connectivity being in everything. And that's why it sometimes is hard for to talk about, you know, an IoT device because they are really, really diverse. I mean, one of the reasons why we talked about a trend is that there are certain characteristics that are combined, but for the most part, it's just a trend towards more and more things being connected, and that helps with understanding what the issues and what the problems are in terms of security. More and more things are being connected in ways that up the stakes a little bit, right? Where things like health devices are starting to be connected. Cybersecurity didn't used to affect your pacemaker, and that is actually a consideration and a concern now. So one of the things, too, to keep in mind, then, is that one size is not going to fit all, right, for any of these things. They are going to be individual solutions, individual devices, with the common thread of connectivity. And with that common thread of connectivity does come these common concerns, privacy, cybersecurity, infrastructure. But within those concerns, right, the concerns are still going to be different, right? You don't necessarily need cybersecurity doesn't work in one size fits all either. Right.
So I think it's a good segue into another question around cybersecurity. I mean, I think we could talk arguably all day about the security risks inherent in IoT. You know, I think about the multiple devices that are out there, from baby monitors to refrigerators to, shoot, my toaster is a connected device. If a hacker got into my toaster and programmed it to only make burnt toast, I'd be miserable. But let's think about, you know, a more serious application of this. People can hack into cars. People can remotely accelerate and decelerate cars and change where they steer. What if multiple hackers get together into multiple cars and decide to target a human target, right? So what are we doing if cars aren't obviously the most applicable example for you two, but what is government doing to ensure that these devices are being protected and that the users are being protected? So start with Tracy, sure.
Yeah, so yeah, you guys have stolen a lot of my thunder, actually. I had prepared a lot of this stuff. But when we look at the Internet of Things, you have to look at it as the Internet of Threats. Obviously, they've talked about a lot of the things that's going on. You have a lot of concerns when it comes to, you know, you have standardization under the normal IT infrastructure where you have standard protocols, standard OSs, standard hardware, you know, across the board. But when it comes to the Internet of Things, you have all kinds of different protocols being used, different gateways, proprietary stuff that are being done. And so that is a big concern of the government, but don't get it wrong that the government doesn't have major interest in this. The government obviously has interest, probably for other reasons that you probably wouldn't want to hear, but their interest is the data that they can collect on person of interest. The problem is analyzing that data. How are they going to capture that data? How do they bring it back into the data center? All that type of, and the amount of data that's going to come in. And most of these companies are also using their own storage solutions to store this data. So bringing all that together. The other side of the house of that, though, is the government is also has been very leery to adopt this type of technology internally to the workspace, obviously for the security risks I just said. So one of the things I would recommend from a vendor perspective is getting together, working with the government, and finding out a way of trying to standardize a lot of these gateways, a lot of these protocols of communication and stuff, because they're going to use things like identity access management to be able to secure these devices, to pull these devices together, to mirror them to users. And there's going to be other things that we're going to want to do through authentication methods for two-factor authentication, maybe biometrics and stuff like that. So.
Yeah.
So specific to identity and access management, do you think that's one of the best ways that we can stop threat actors from hacking into devices? And
well, it allows us to gain more control of the devices that we have out there, and then we can sit there and start using those attributes to tie those certain devices to individuals and stuff like that. One of the things, as I'll tell you, is the government's hands being forced to bring in certain, let's say, Internet of things. When it comes to things like they're using iPads now, they're using Surface devices, but they're also on the medical side of the house where people are actually having to come in, and you'll have an insulin pump that actually sits there and has to send information back to the cloud so their doctor can sit there and monitor these things and everything else. Or they're using like also health devices, which are Fitbits and stuff like that. But again, the security risk that comes with that, we've just talked about, almost all these devices have been hacked, and you've got to assume they will be hacked. So.
Yeah, go ahead.
You go first?
No, I was
Landon,
I was just talking about the vehicles. Yeah, go ahead.
So I'm going to put something out here for everybody to just think through. So to Tracy's point, inevitably some of this security is going to have to live at the gateway because the endpoints are not going to be terribly smart.
Yep.
How many credit cards are in this room right now, do you think?
Probably about 100.
And
60, 70?
There's about 10 billion credit cards that are functionally connected today. And actually, the hack rate on credit cards is amazingly low. And part of the reason is because we don't actually protect the credit card, we protect the behavior of the credit card. We do some things now. There's a small chip on it that says it's really a credit card, but for the most part, we actually monitor behavior and we turn things on and off based on behavior. And to Tracy's point in the gateway, as much as I'd love to think we can not, some devices will, a heart pump can probably have enough MCU power in it, and the medical device is expensive enough that we can put enough MCU power, we can put crypto in it. No question about that. But lots of things where we can't, we'll probably manage this much like the way a credit card works versus the way IT works. And my encouragement to the industry, and I'm much more positive about this than I think some of my colleagues around the industry are, is that we're going to actually not solve this like we solved anything in IT. I think we're going to solve it a lot more like we did around credit cards. And I think it's the banking industry has a lot of answers for us inside this solution. And it'll be through the gateway.
Landon, do you have another comment?
No, I would agree. Two things, on the gateway and then on the actual device. So like for vehicles, one of the challenges the State Department has is we want to be able to pull the information off of our car computers and understand how the vehicle's operating, if we're getting hard stops, if we have a safe driver or not. We don't own the cell towers in every country, and most of these vehicles right now use cellular to communicate with the vehicle. And for us, we had to figure out a way to take all 14,568 of our vehicles, which are different makes and models, and figure out how we can universally grab that information. So ultimately, we came down with stripping one of the devices that pulls that information out and dumbing it down on the technology or on the communication side, so they only communicated with certain methods that we wanted, and took everything else out, but then locked the car so the car could not use its cellular communication at the same time. So on the device side, we were forced to come up with our own solution.
Protocol stack,
For,
yeah.
yeah. But on the gateway side, which I would agree with Stephen is right, that's where our security is. And what we want is to have as many dumb sensors as possible on one side. So dumb that even if you hack into it, so what? You're going to get, a little bit of information on how often our lights turn on and off or whatever.
Nothing sensitive.
But it's the gateway which protects the platform, and it's also the gateway which allows us to keep an eye on what's going on with our sensors anyway. So that's our additional security layer. We can actually monitor what's happening out there. Because those sensors are out there in the first place, one of them goes down, we know something's up. So, but it's the gateway. And then we'll go into AI later, which is why the gateway is so important.
And there's actively work being done on that. I mean, the flip side of the dumb sensor getting hacked and not being able to pull a lot of information off of it, that's usually okay for the end user. But when it gets turned into part of a botnet, then that becomes a serious problem. And the administration has put out a cybersecurity executive order, with many tasks, one of which is instructing NTI, the Department of Commerce, NTIA and NIST, along with the Department of Homeland Security, to put together a report on botnets. And gateways have been a significant part of that conversation. And one part of managing how these sensors work, there is a standard that's being actively discussed and developed called the MUD standard that looks at how how a device should be interacting with the gateway, and then shuts down devices that aren't interacting the way that they're supposed to be. And also, NTIA is just including a process on patchability and upgradability, and I would highly recommend taking a look at some of the working documents that have come out of that process, one of which looks at what are the different types of technical specifications or technical capabilities of different devices, and whether and how they can then accept or not accept patches. So looking at that, the super dumb sensor that doesn't have any ability whatsoever to even have encryption on it versus something that is almost a computer. So patchability, but then also in terms of how it interacts with that gateway are two very important questions.
I think the new mantra for the day is sensors are stupid, so we can all
Yeah.
walk away with that.
I like stupid sensors versus smart sensors, and the reason being is if I'm monitoring one of my embassies overseas, so we're in 274 cities, we have 26,000 buildings around the world that we monitor, and each building we can pull about 15,000 data points from that building. But the only way we can do it in a cost-effective way is if we have extremely stupid sensors out there.
Yeah.
Because the moment I put a computer chip on there to do anything else besides ones and zeros, my cost goes through the roof. And so for me, I'm looking at a practitioner. I need it cheap.
I think we hear a lot of consternation from government customers over how to centrally manage and effectively manage their sensors. I think State Department is a great example of what you can do to effectively manage that. I think that one big question that looms for me is around the data that's actually being collected and around its governance. So I think about a lot of companies in industry that are requiring their employees to wear Fitbits so that they can lower their insurance premiums. Does anybody have to wear a Fitbit for work? Nobody here? Okay. So in that example, who owns the data? Who owns the security of the data? Is it on the company who's requiring their employees to wear the Fitbit? Is it on Fitbit? Is it on the insurance companies? Is it on government agencies? And if none of the above, then who? So I'm really looking at this from an oversight standpoint. What are we doing to make sure that citizens' personal health data is not being misused? And I'll start with Landon and work our way down.
I think we have a law.
Well, so I'll actually jump in on this.
Okay.
I think I'm the policy person
Yeah,
on this.
sure.
On this. So we actually don't. We do and we don't, right? Because we do have HIPAA.
Yeah,
Right.
That's what I was referring to.
We have HIPAA, but HIPAA only covers health information that's actually produced by a healthcare provider.
Right.
So Fitbit actually falls into both of those categories, right? So Fitbit, if it is being provided by your insurance company, the insurance company is collecting the data, or your pharmacist or your doctor, that is covered by HIPAA. And Fitbit has actually created separate servers, separate protocols for the data that is collected through that process. health data that is not produced by a healthcare provider is not covered under HIPAA. And this is something that HHS has been looking at for a long time, that Congress has held multiple hearings over. What it is regulated under is the FTC Section 5 authority against unfair or deceptive practices. So that basically means that whatever Fitbit puts in its privacy policy, the thing that I'm sure every single one of you who has a Fitbit has read thoroughly and ensured that you have consented to, whether or not they are actually doing what they say. And that's the deceptive practices. The unfair is whether those practices are actually okay. And the enforcement of the unfair depends a bit on who the sitting FTC commissioners are. So, so in terms of oversight, we have a bit of a fractured system. It is in direct contrast to what's happening in Europe right now with the General Data Protection Regulation. For those of you who might have any business over in Europe, I hope that you and yours are thinking about this and thinking about compliance, because this is going to hit like a freight train. And that is very much top-down compliance-based regulation. Whereas what the U.S. does is primarily self-regulation. You know, you self-attest what your practices are going to be, and then that's enforced by the FTC, with the exception of children's information, health data that's produced by a health provider, and credit information, financial and credit information. So that is the active oversight. But a large thing that, in terms of how you relate to the government, what's going to happen, and what I think you're going to start seeing more of as more of these devices start collecting more and more data, is contractual clauses, right? Is the government agencies being actively concerned that if you are collecting PII through this device, and if it is going through your servers, that you are actually following the government policies and you are not all inadvertently breaking the law. So that is something that is going to be coming down, because the Privacy Act does cover government and how it handles PII. It doesn't handle the private sector. But if you are providing data services for the federal government, as some of you might already be aware of this. This is going to be something that if your manufacturer is moving into this space, you're going to have to consider.
So regarding personally identifiable information, we've got some form of centralized oversight and regulation. I feel like a lot of oversight and regulation is a bit fragmented across the federal government. I mean, let's be honest at this point, do we think that A, there is a need, and B, it's feasible to say that there will be a governing body over IoT, similar to what happened with DHS after 9/11, you know, that conglomerate of agencies formed? Do you think we'll have something similar with regard to IoT, or need to?
So I think that our hands are a little bit tied in terms of talking about that, because we don't. I'm not sure what the administration's position would be on that. I don't think that they have yet a articulated position on IoT, or what the policy stance is moving forward.
From an industry perspective, then I don't mean to put you on the spot.
Yeah, I would say from a policy perspective, I think we're a little bit behind the times. And I'm not an expert in this, but I would assume that you have to assume that these companies are going to use that data. Every time you sign, you log into one of these devices, they ask you, are you willing to share your information? Most people don't even look at their, right. Yeah, share it, put it on Facebook, do whatever. So you have to understand that they're using this information, obviously, to make money off of that. They're going to share it to the industry and stuff like that, unless you physically make sure when you sign that thing, you're saying, do not share my information.
Right.
So let me give you a real-life case study of this outside of medical. And to the policy folks here, I want to, you know, as much as you might not be able to answer that question, the FCC specifically has done a lot to make IoT work, and we should be really thankful, because the way they've handled frequency bandwidth over the last 10 years, we wouldn't have IoT if we didn't have Wi-Fi for nearly free, right? We were very fortunate in the way that this has actually played out. But the real problem is going to actually come in something like this. Let me give you a real life example. So Siemens has an IoT platform, and they basically designed it around their products, right? So if you have Siemens manufacturing gear in your facility, Siemens now wants to collect all the data off that. Whose data is it? And here's an interesting problem. You probably didn't buy the Siemens equipment, you probably leased it. So you actually don't own it. The data you're getting off of it, if it relates to the product you're manufacturing, might be yours, but if it relates to the machine that you don't own, it's probably not yours at all. And the decision of what data comes on that or off that is actually made by the manufacturer more than it's made by the the company using the machinery. So this becomes really complicated, and companies like Sight Machines, I'm not plugging them, they're not a client, is exactly kind of an analytics company is trying to figure how to parse all this stuff out. So Siemens wants to know if the machine's running right, because they want to send in a technician if it's going to fail before it fails, right? And they also want to have all this information, know how it's being used and when it's being used, because that's really valuable data so they can make better machines. This is actually a real company that I was speaking to in Wisconsin that makes, the fake floor stuff that and how to explain it, the flooring tile stuff.
Yeah, those hardwood flooring.
Engineered
Those
hardware.
fake-
Yeah.
So they make this stuff, right? And they make it on Siemens cutting machines. And they have to make exact cuts. And if it isn't perfect, it goes into the waste bin, right? So they're trying to get the data off the cuts so they can adjust the cuts of every single cut. And so the way they do it today, which is some guy at the end of the day goes and adjusts the machine. So they adjust it one time a day. They want to adjust it every time there's a cut, right? Because they can get much more accuracy. Well, somehow now you got to parse that data out. Because we don't want Siemens to know about how many times we're cutting the thing, because then they're going to charge us more for it, and they're going to try to start charging us by the cut, right? And the manufacturer doesn't like the fact that Siemens knows all this information. And this is the type of commercial, I'm going to use commercial because it's a little safer place to play. This type of concept, we've never faced it before. So people ask for what's the policy? It's like, well, we're trying to figure it out. Mm-hmm. And it's probably going to get down to the data about the machine. If it's on or off, is going to probably go to the company that owns the machine, Nuri, right? So the heart pump maker is probably going to get the information if the heart pump is working. That's type 1. We call that, I call that device identification, different than what he does. Yeah. But there's a device there, it's working. The second thing is the device operating and functioning correctly? Now for a hospital, they want to know if the blood pump's working so they can bill you, right? So first they want to know it's really in room 6C, then they want to know if 6C's room is on so they can bill you. And the third part is the content data, which is how much blood pumped through it, what's all the personal information. So if you think about it, the world's going to end up parsing IoT into these three kind of data pools. And those data pools are going to have to get parsed at the gateway, by the way, it's where they're going to get parsed, and they're going to go to 3 different places. And that's how the problem will eventually get solved. And the regulatory part of this, frankly, Europe is probably going to drive the US. Because any commercial company in the United States who does any business in Europe, no matter what, they're going to have to go to the most strict model. That's what they're going to have to do. And probably here it's going to be Europe in the world. I think they're going to have a stricter set of data protocol management than we will.
Well, thanks for that insight. I've got a host of other questions that I'd love to get through today, but we've got limited time, and I want to give the audience an opportunity to ask some questions as well. So Kevin's got a microphone in the back, so if you want to raise your hand, wait until you get the mic in your hand, give us your name, company you work for, and address the panel with your question. So who's got some questions?
You own the gear.
We answered all of your questions. I've got one in the back. Okay.
Hello. My name is Dennis Defensor from Defensor Dynamics. About 10 years ago, we had a lot of cloud sessions like this, and we never got past cybersecurity. But we did after a few years. How do we get to that level of progress in IoT? Because the last 5 IoT sessions I attended, it tended to stop at cybersecurity. But we had the same thing with cloud 10 years ago.
Cloud was kind of a buzzword for a long time without any real traction around it, and people got frustrated in industry because we didn't see it. And so I think IoT is kind of that way. It's been a buzzword for the last couple of years. We're starting to see it being implemented a little bit, so I think that's a very relevant question. But I think Stephen touched on that a minute. But
I would say Stephen has been talking about the gateway. The gateway is critical for that cybersecurity piece. And the fact that we're in the cloud now, at least for the State Department, it speeds everything up because there are certain things that we aren't able to do with our own data centers that we can do in the cloud that can interact with the gateways. The gateways are becoming more sophisticated. What we put on them is becoming more sophisticated. So I don't see IoT hitting that huge slow speed bump that you're referring to. It's because we have cloud access, we're going to get IoT. In fact, 18 months from now, I will probably be working on the AI portion of the IoT rather than just get the information. I will be, running through the AI process, and then the second part of an IoT device. If you think about how dumb the sensors are, many of them might be dumb, but they might also have the ability to turn something on or turn something off. So that's the action, right? But the action's not going to occur until I understand what my patterns are from the sensors, and then teach the AI what I want it to do when it sees that pattern, and then that's the action. So I see myself with our team doing that action part, 18 months from now. So, the IoT is not, I don't see that slowing down.
We're not going to have the same roadblock and same stall out in terms of adoption because there's not going to be as many concerns, or at least we've gotten over the hump with those concerns.
Well, I think that there's two things. One is IoT's already here, right? I mean, we already have, how many sensors do you have in buildings in how many different countries, right? I mean, we're already doing this. It's just a question of, again, this being a trend and an exponential trend of this becoming larger, more and more things being connected. I think the second thing is that I don't think we're ever going to solve cybersecurity, right? Like, we haven't solved cybersecurity for basic computers, right? And that's where thinking about this is heading, right? It's not towards solving a problem, it's towards risk management, right? That's what the NIST cybersecurity framework is about ensuring that organizations are able to build risk management practices into their development cycles, into their day-to-day practices, and so I think that we're going to see that risk equation and those practices develop as more and more things continue to be connected.
We had a question up here, Kevin.
Sure. Yeah, I'm Vince Ritz, CSRA. I'm going to try to pose my question where it makes sense, but I think it centers around the gateway. We have a business environment where we bring our IoT into. So would it be like different gateways, one for business, one for home, one for maybe other sectors, and we have to register our node devices to the different places, and all that node management for everybody? Or,
Yeah.
because you can't always bring your cell phone in some places and whatever.
So let me try to simplify that answer. So we already have the gateway for the home. It's called the Alexa. I mean, that's, it's already solved, right? Whether you use Amazon's or you use Google's, whoever you're going to use. I mean, congratulations, they figured it out before everybody else did. Voice is the killer app in the house. That's what's going to work. For commercial, the place that we see the biggest weakness right now is there's none of the IoT platforms today have very good device control. So where companies like Wise and iGel, and I will make a claim, I am doing some work for iGel, where Wise and iGel basically said, okay, if you're going to have 10,000 virtual desktops, we got to control them, we need to know where they are, we need to know if they're turned on. We really don't have that yet in any of the IoT platforms. And I think the next big development you're going to see is device control, because then you can do endpoint authorization. And the reason he has a hard problem right now is there's no centralization of device control, so I can put up a panel that says, okay, I've got 270 buildings around the world, I've got 15,000 sensors in each one, and I can just drill down and find right down to the sensor, right? Nobody's got that either operationally mapped or visual in a product that you can buy today and install for your client. And I think that's one of the things we're missing in the gateway. I have a lot of theories about why we haven't done it yet, but I believe that's where it'll go. And it'll be very, very much like the way we virtualize a network or control a set of virtual machines. It'll be much like that. And that's why the gateway is going to become important, because you don't want to do that up at the application layer. You want to do that close to the physical element itself.
And I was just going to jump on what you just said. So that's why it's important for us from an identity access management standpoint is for us to make connection into systems or users. We use, connector. But since there's so many different types of gateways out there, we're going to need standardization on that,
right,
where we can sit there and make that connector into that gateway and then manage all those devices to the very endpoint. So that's the major concern that we have.
It'll be virtualized at that level.
Absolutely. Yeah.
Which, by the way, ties to the idea that we have to parse the data, because then you can tell each sensor, oh, your data gets parsed. You start to see an architecture that actually makes sense.
Start to see a lot of opportunity coming up from this this conversation. All right, I think we've got time for one more question here.
Yes, Eric Sindelar from Supermicro. It was more of a comment that I totally agree with Stephen. And there's a couple of companies that are still in stealth mode out in the valley that are working on this right now. And I think you'll see that start coming out of stealth mode next year. So I don't know if it'll be a standard mandated by the government as much as a de facto standard where the market will decide who the winners are. But it's absolutely in works.
Well, for those of you who are integrators and who are putting in systems, this is the key missing thing to make IoT a business for you. And when this happens, and it will, and I think it will be sooner than later, that'll give you the ability to control 10,000 units, 10,000 devices into a central hub that you can then have device control management on top of, and that you can, and then you can start to put policy into it, right? Because you can't put policy into something you can't control.
Yeah, I could tell you that for us, the companies that came to us that had the parts to make that standardization, at least for the department, possible, they were easy to find in the sense of, okay, I have a crowd of people offering, and that's the one obviously I have to go with. But if you have that, if you guys are integrating and you're providing that as an offering, it's an easy no-brainer for us to pick your company then. So.
I was wrong on the time. My watch is a little bit off, so I actually want to get one of my questions in before we go back to the audience real quick. So I think there are endless use cases for IoT in public sector to help our government deliver services to constituents. And the applications are endless, from healthcare to transportation to infrastructure. In your best case scenario, in your utopia, what are some examples of how industry could partner with government to create IoT solutions within the next 18 months? What are some examples within government that you think you could come up with right now? Start with Trace.
I would say it's starting with that communication, sitting down with the vendor and the government itself, and asking those questions, saying, look, from a government perspective, the public's perspective, what are your concerns? How can we meet those concerns? What are the security requirements that you have? How can we also meet those? And and go down that road. Without having those questions and those answer sessions, I think that's going to be really hard to get there.
Mm-hmm.
So.
Open communication with customers.
Yep.
Yeah, I mean, I would absolutely echo that sentiment. Again, so the NIST cybersecurity framework is being rolled out for federal agencies. They should be actively implementing them. So they should actually have a risk strategy in place where you can actually connect and you can have this conversation, where you can actually say in an organized way, what are your needs, what are the things that we can do, how can we plug in? And I also want to plug that the Department of Commerce is not just simply us sitting in our offices thinking about these things. We're also NOAA, and we're also the Census Department. So we actively have lots and lots of cool devices and sensors out there monitoring whale movements, monitoring the atmosphere, actively right now in the field helping to ask census questions and make sure that data is properly stored and secured, but done in a way that enables those census takers to go out into the field with their devices. So we're, like I said before, IoT is already in place. It's already something that is actively happening. And I, for one, am really excited about where it's moving towards as we move forward.
So we see kind of three areas commercially, and I think they mimic in government too. That seems to be where most of the growth is going to come from. Retail is actually going to be a big POS is already there, and smart stores. Now you turn that. And look, Amazon just bought Whole Foods. They didn't buy it because they really want to be in the grocery food business, right? They want to make smarter stores. And we all have to buy food, so it was a good thing to buy. But you take that concept of asset management and utilization tracking, and you put that into any government agency. So asset management will become a very, very big part of IoT. A lot of IoT is just going to be knowing something is there and it's being used. The other piece, and we've talked about medical a little bit, but the average mid-sized hospital has 10,000 devices in it, and a 20% underutilization rate because we don't know where the thing is. So you buy 2 of them. And this isn't a government statement. This happens in commercial hospitals all the time, right? So if you know more about the assets you have in a heavy asset environment, you can buy fewer of them, utilize them better, right? So we know that IoT, just simply knowing where something is going to be a big business for you guys. And that's a big piece. Manufacturing may not relate nearly as well to the government aspects of it, but certainly running machines smarter and monitoring them more often will increase utility. And at the end of the day, all of the fancy things about analytics and analytics and analytics is really going to come down to something simply in better utilization of the assets that we deploy, and it's better utilization of capital. The real value of IoT for the next 20 years is going to be capital utilization. That is going to be the big thing, whether it's a car, right? So if our cars are autonomous, they're going to get used better. So we spend $50,000 for a car today, $30,000 to $50,000 for a car today. Utilizing that better means we're going to be able to own it longer. And the biggest industry that's really driving all of this at the end of the day is going to be the insurance industry.
The insurance
industry. Because it's the reinsurers to the hospitals that want those assets used better, right?
Right.
It's the insurance companies in the car want to see accident rates go down. It's really a fascinating world, and it relates to the government in the fact that they have how many vehicles?
State Department, 14,568. That's only the State Department.
So you look at across the gentlemen that are here, and you can imagine the efficiency that has to get brought in, can be brought for a very, very small amount of money to very, very, frankly, very budget-conscious environments like the government.
Right.
When we look at asset tracking, I think RFID tracking was a step in the right direction for the DoD, but I think there's enormous opportunity for vendors out here that sell to the DoD to bring more efficient asset management and tracking capabilities utilizing IoT technology. Landon, do you have something else to add?
Yeah, no, on the management side for state, that's what IoT is all about. It's about using all of our assets most efficiently. I can look at the cost-benefit analysis just for our smart metering program alone. It was embarrassing of how much of a benefit it was, so we actually tried to undercut ourselves because it just, a $30,000 activity yields about $9 million in savings because we're able to extend the life cycle of our equipment. And our equipment by itself is $500,000 just to have a good HVAC system in our embassies. So we're working on other things like the Halo lenses that Microsoft has. For us, we spend about $80,000 to about $150,000 for a contractor to go overseas to take a look at a building automation system and figure out what's going on. For us, we're looking at a $2,000 Halo lens that has instructions to the person on the ground to say, look at this, turn this report back, or videotape it and send it back to us, would reduce that activity, which happens 4 or 5 times a week. We could save a lot of money.
Yeah.
And so for us on the management side, IoT is definitely, there's nothing to replace it for benefit.
Absolutely. All right, time for about 2 more questions. I think I saw one in the back.
Yeah, you had
Mind waiting for the microphone? Thanks.
you had mentioned that part of the solution, again, for IoT, for security, would be similar to what credit card companies or financial institutions
It's
did.
my thesis, yeah.
Yeah. So how do you think that would apply? And again, this is the internet. Yeah. Thank you, Al Gore. How is it that we utilize? Where is it that you see the similarities, and how will they utilize that
Sure.
on the internet? There?
So this is not a government policy statement, right? I don't work for the government. So if you take a look at the similarities between what we do with credit cards and how we use them, and the amount of cost of them, and the amount of frequency we use them, it's much more similar. IoT devices are more similar to credit cards than they are to PCs. And if you look at the way they work on a network, where they're often detached and then reattached, that's much more like a credit card is much more, an IoT device is much more like that than a PC. A PC is continuously attached to a network, or tablet, or even if you take a tablet and you put it out in the field for census, it's going to be on a LTE 3 or 4 network, and it's constantly going to enjoy the engagement of that network and then therefore the monitoring of that network. But that's not how a credit card works. A credit card only works when you actually put it into a POS machine, right? And that's how an IoT device works, right? You don't sense the moisture in groundwater every second. You measure it based on the number of times you want to take that measurement, and the rest of the time it's sitting there dormant, which is when you're going to go attack it, is when it's dormant. So the similarity is much closer. So, to give you an example, companies like Experian have taken a very close look at this, right? These are the people that are behind that credit card security, and they keep coming back and saying, this is a behavioral problem. You manage behavior, and when something isn't behaving correctly, you shut it down. So example, if you're supposed to take 100 water samples per 24 hours and something's trying to take that water sample 10,000 times, probably been hacked. The DDS hack was exactly that. It was over processing the radio. It's telling the radio to transmit. Radio wasn't supposed to transmit. Why didn't somebody know that radio wasn't supposed to transmit? Because there was no policy written that says that radio is only supposed to transmit this many times. Let's shut it down. So at the end of the day, we're going to manage this 10 billion network of things. We're not going to manage it by all of it by putting keys all over the place, because there isn't enough intelligence at the endpoints for the keys. So the gateways are going to have layers that know what devices are out there, how many that are out there, what they're supposed to do, and when they don't do what they're supposed to do. What you want to find out is when the guy hits the brakes too hard in the State Department truck, you want to go call him up and say, hey, you're driving like a crazy man, right? But you don't need to monitor brake when the car's off. So that's why it's more like a credit card. That's why I say it's more like credit cards.
Although you want the AI analysis coming back to our central place to tell me, as the car is coming in, that driver was driving dangerously, and you should have it go.
And you do want that, right? And that's where the AI piece comes in.
That's when
right?
you come into risk-based analysis.
Yeah.
You want to be able to, or risk-based behavioral analysis, where you have a trend that's a historical trend that's telling you that this is not the norm.
So think of it this way. There's an aspect of whether the device is doing what the device is supposed to do, when it's supposed to do it, and then the data you get might tell you somebody is doing something bad. You've overwatered, you've underwatered, you've overbraked, you've underbraked. That is different than the issue of whether the device is actually collecting data the way it's supposed to collect data. And you have to separate these two things in the conversation.
So for the U.S. embassies, we have generators at all of our facilities in case there's a blackout. And anybody can go online and see this infamous video that I always get to see with all of our security guys, because they always say, oh, what have you hooked up to the building this time? And then they'll show me this video of a generator, and all they did was send a command to the generator to turn off and on in a certain pattern, and it blew itself up, right? So it identifies to us, okay, so we can have a tunnel to the controls of a generator, but that's not going to actually keep the generator safe. We actually have to teach the gateway what commands are allowed to hit that generator in the first place, and at what parameters of safety would those controls be, or those commands would be. And if those commands are outside the parameters of safety, the system should be smart enough to kick it out, and of course alert us that somebody's monkeying around with our stuff. So
I wish we could keep the conversation going. This is great, but unfortunately we've reached our time. I'm sure some of the gentlemen would be happy to sit and chat with some of you afterwards, but I want to thank you all for attending here and being part of this, and thank you all for being part of this panel, and hope to see you for the networking session later on.
Thank you. Nice to meet you.